Hi, I'm Max Guernsey with Protocore, and in this video I'm going to show you how to decouple a class from something that makes it hard to test. In this case, the thing that I'm going to decouple it from is the system clock. Here we have a fairly simple algorithm. We have a class called Flash Sale Manager with a method called Schedule Flash Sale. That method schedules four things to happen. 30 minutes before a flash sale starts, it pushes out an announcement that it's about to start. When the flash sale is supposed to start, it opens up the sale and also pushes out another announcement. 15 minutes before the flash sale is supposed to close, it pushes out a warning. And then when the flash sale is supposed to close, it closes the sale. It's very simple to do, very simple to write, very simple to understand, but it's actually very hard to test. And the reason it's hard to test is that this schedule action method is coupled to the system clock, and it generates real delays. So in order to test this, you would need the test to run for something like 45 minutes, 46 minutes. It would take a long time. And that's not even dealing with all the flakiness that comes from building delays into tests. So what we want is not an actual timeline. We want a virtual timeline that works enough like the actual timeline that we can trust our tests without having the test for this code taking 45 minutes. So let's get started. I am going to start by making a variable. Schedule action is the thing that I want to encapsulate, so I'm going to pull it into a delegate variable. Then I'm going to make a method. Now, it doesn't matter what the name of this method is. It's really just an intermediate artifact to support the next step. So I'm just going to give it 2 underbars as its name. Once I've done that, I can transform parameters and create something called actual timeline. This is going to create a data object that stores the delegate for the scheduling method and cause it to be used throughout the rest of this algorithm. So see, it created this actual timeline, and it instantiates the timeline for the return value and returns that, and then everywhere where I use the delegate, I get it as a property from the return value. So I'm going to then inline this method. I don't need this method anymore. It was just a temporary artifact, like I said. So I'll inline the method, and I will extract another variable for the object itself. And we'll just call that timeline for now. Now I've got a bunch of variables I don't need, so I'll simply clean them up. I'll inline this guy, I'll get rid of this meaningless cast that it injects for some reason, and I'll inline this guy. So the next step is to convert this from something that is a data object that just stores a delegate into an actual class with real behavior. To do this, I'm going to start by figuring out how to get rid of this constructor. And the first thing I notice is that this constructor is only called in one place, and it's only ever called with one static value. So I can just take the parameter and inline it manually, and then get rid of the parameter and get rid of the explicit constructor. Okay, so now I have a timeline object that at least self-initializes correctly. But I really don't want to have a delegate here. What I really want is to have a method. And it turns out that that method is going to have the exact same signature as this schedule action method. So I'll just copy that signature and paste it here. That's a safe thing to do. That hasn't changed the behavior. I've created a new private method that we know isn't called anywhere because it's private and it's new. What I want this method to do is I want it to call the result delegate, and it's going to need a few parameters. So I'll just pass these parameters through. And since this method isn't called, we know it's safe to make it public. So I'll make it public. Now I have a public method that does exactly what result does, which means that anywhere we're calling result, we could just as easily call schedule action. So I'll go ahead and replace all of those calls to result with schedule action. Now I want to get rid of this result, which means I want to inline it. Well, in order to do that, I need to make it a computed property. Once I've made it a computed property, I can simply inline it like I would any method. I don't need that. And now I encapsulate the method call to this static method in this object method, this instance method. So the next thing to do is to extract an interface from this class. So let's do that. I'll extract an interface. I'll call it timeline, and I'll make sure that it includes the schedule action method in the methods that get pulled up. Now I have the exact same class as I had before, which has the exact same behavior as always, but it implements an interface. This means that I can introduce a parameter and use base type where possible. And voila, this schedule/sale method no longer is directly coupled to the actual timeline. A test could substitute a mock or a fake or whatever for this interface and execute quickly and reliably. Once again, I'm Max Guernsey. Thank you, and I hope you enjoyed it.